Assalamualaikum and hello to all. Today we are going to proceed to chapter 5, which is hydroxy compound or alcohol. So 5.1 is nomenclature and 5.2 is physical properties. Learning outcome. Okay, so at the end of the lesson you should be able to draw and name the structure, classify primary, secondary or tertiary alcohol, and then physical properties, compare the boiling point, and also the solubility. Okay, so alcohol, it is being presented the general formula CnH2n plus 1 OH. Okay, for example, if n equals to 2, it means it will be C2H, 2 times 2 times 2 is 4, so this one will be 5 OH. Okay, so that is the general formula for aliphatic alcohol. And there is one more, which is aromatic alcohol, which is phenol. Okay, if I draw the structure, phenol is like this. It contains benzene ring with OH, so this is phenol. Okay, OH attached to the benzene ring. Okay, this is alcohol, aliphatic alcohol. This is also aliphatic alcohol because OH is attached to cyclohexane, not to benzene ring. And this one is also aliphatic because OH is attached to the methyl group here, not to the benzene ring. Okay, so if we can see from here, all these are aliphatic alcohol. Okay, the differences is that OH is attached to the carbon that is not benzene ring. Okay, OH attached directly to the alkyl group. Okay, carbon that is not benzene ring. Okay, this one is phenol. This one is 1, 2, 3 bromophenol, and this one is 1, 2 methyl phenol. Okay, so aromatic or aliphatic. Okay, this is aromatic. Why is it aromatic? Because OH group here attached directly to the benzene ring. OH attached directly to the benzene ring, and OH is attached directly to the benzene ring. So this one is aromatic alcohol. Class of alcohol. Okay, we can classify this into, okay, let's see this one first. Methyl alcohol. Methyl alcohol because all of the hydrogen here attached to the carbon. Okay, carbon here attached with all hydrogen. So OH that is attached to the carbon that only have hydrogen attached to it is called methyl alcohol. Okay, now we can see that OH is attached to carbon that have 1 R or alkyl group, 1 R. This is R, alkyl group. So this one means that the carbon here is primary carbon. So OH is being classified by the carbon, the class of carbon that it is attached to. So it means that that one is primary alcohol. And this one, you can see the carbon here is attached to 3 R. R is alkyl here. So it means that this one is tertiary carbon. So OH that attached to the carbon that is tertiary means this one is tertiary alcohol, and so on for secondary alcohol because that carbon only attached to 2R. So this is secondary. So it means this is secondary alcohol. Okay, now we want to name this structure. The step for naming you already learned in the topic of alkane, alkenes, and benzene. So this one, I assume you already know how to name the structure. But let's try to name the structure. Okay, so OH, you only have one functional group, that is OH. So you need to find out the longest chain with the OH attached. Okay, so the longest chain, I think this one. So this is the longest chain. Okay, so this is the longest chain. So how many carbon are there? 1, 2, 3, 4. Okay, so if this one is 4 and OH is attached to carbon number 1, the parent chain for this one is 1 butano. Butano refers to 4 carbon alcohol, and there is substituent here, methyl, and this one also methyl. This one attached to the carbon number 2, so this one is 2 methyl, and this one is also methyl, 2 methyl. So when you have 2 methyl, you are going to put the word dimethyl and this one attached to the same carbon. So for both of these substituent, we are going to name it 2,2-dimethyl. Okay, 2,2-dimethyl. Okay, now we want to combine these two names, the parent chain and the substituent. So the name for this compound is 2,2-dimethyl dash 1-butanol. Okay, 2,2-dimethyl dash 1-butanol. And the class of the alcohol here, if we need to classify, okay, so if you look again, this carbon only attached to one R. All these are 1R. All these are 1R. So primary, so this one is primary alcohol. So if we were to classify this one is actually primary alcohol. Okay, so let's see the real answer. Okay, type primary alcohol and the name 2,2-dimethyl 1-butanol. Okay, so we are correct. Okay, what about this one? Okay, remember, you need to find the longest chain with the OH group. Okay, so longest chain, I think it is this part. Okay, so that is the longest chain. So let's try to count the carbon. You can count from the left, 1, 2, 3, 4, 5, or you can count from the right, 1, 2, 3, 4, 5. Okay. Okay, so let's see the substituent. You have one substituent and two substituent attached at the same carbon, carbon number 4. So whether you count from the right or from the left, it is the same. So it doesn't matter for this one. Let's say we count from the left. So alcohol hydroxy group here for this alcohol is attached at carbon number 3. It is attached at carbon number 3, and the longest chain is 5. So 5 is pentane. So this one is alcohol, so it will be pentanol, and the hydroxy group attached to the carbon number 3, so it will be 3-pentanol. Okay, 3 because the OH attached to the carbon number 3, pen because it is 5 carbon atom, and OL because it is alcohol. Okay, so for the substituent, okay, we are going to use this numbering. Let me erase this one. We are going to use the numbering from the right, from the left. Okay, so you have 2-methyl, and then you have 4-methyl. Okay, you have 4-methyl, and this is the same. So it will be 2,4-dimethyl because you have two same group. So this one, if you combine, it will be 2,4-dimethyl dash 3-pentanol. Okay, and for this one, the class of alcohol, you look at the R. So carbon here attached to one R and only 2 R. So this is secondary alcohol if you were to classify this one. Okay, so secondary alcohol. So let's see the real answer. So secondary alcohol, 2,4-dimethyl 3-pentanol. So we are correct in naming for this one. Okay, now we have cyclic compound. This is not benzene, this is cyclic compound. Cyclohexane actually. Okay, so first we need to find the longest chain, right? But remember, when you have functional group, you need to give priority to that functional group even though you have longer chain, longer cyclic chain. So this will be your parent chain. Okay, so this will be your parent chain, which is 2 carbon. 2 carbon is ethane, and you have alcohol, so it will be ethanol. Okay, ethanol. Okay, for ethanol, your OH is at carbon number 1, so it will be 1-ethanol, and this one bromine attached at carbon number 2, so it will be 2-bromo, and also cyclohexane here attached to the carbon number 2, so it will be 2-cyclohexyl. So if you combine everything, the name for this compound will be 2-bromo dash 2-cyclohexyl. carboxyl dash 1 ethanol. Okay, and the class of the compound, this one only attached to 1R. Everything here is considered as 1R only. So this is primary. So type is primary alcohol. Okay, so let's check the real answer. Okay, primary alcohol, 2-bromo 2-cyclohexyl ethanol. Okay, sometimes for ethanol we didn't write down the number 1. We didn't write down number 1 here because ethanol, you can only have alcohol at position number 1. You cannot have alcohol at position number 2. Okay, so we can choose this naming, 2-bromo 2-cyclohexyl ethanol. Okay, now what is given for you is the name. Okay, it is primary alcohol and secondary alcohol. Okay, so 2-third-butyl 4-chlorocyclopentana. Okay, this name looks long, right? But actually what you need to do is to find the parent chain. So the parent chain is this thing, cyclopentanol. So draw cyclopentanol first. Okay, pentanol, 5 carbon atoms. So cyclopentanol is like this. Okay, this is cyclopentanol. Cyclopentanol means your OH is at here. You can also use at this part, but when you draw at any part, this carbon will be carbon number 1. Okay, that one will be carbon number 1. Okay, carbon number 1. Carbon number 1, and this is carbon number 2, carbon number 3, carbon number 4, carbon number 5, and you have 4 chloro. So 4 chloro is here, and 2 third butyl. Okay, third butyl means this one is tertiary butyl. Okay, so this is the structure. Okay. Oh, I cannot undo. Okay, let me just draw. Okay. Okay, you can draw better than this, I think. Okay, so this is 2-third-butyl 4-chlorocyclopentana. Let's see whether the drawing is correct or not. Okay, yes, it is identical, right? Okay, just that it is much better drawing. Okay, so remember, for you to draw the structure from the name that is given, find out what is the parent chain first. Okay, draw the parent chain first, and then attach the substituent that is needed. Okay, write the structural formula for this one. The same thing. Okay, this one you have diol, methyl hexane diol. So actually it is hexane. This is not cyclic, hexane diol. So if you were to draw, okay, I draw skeletal, 1 2 3 4 5 6. Hexane is 6, so 1 diol means that you have 1 OH here. 1 2 3 4 5. Okay, so this is hexane 1,5 diol. 4 methyl, so this is 4 methyl, and 3 sorry 1 2 3 4, correct. 4 methyl and 3 chloro. 1 2 3 chloro Cl. Okay, so let's see the drawing. Okay, correct, okay, OH Cl, methyl, methyl. Okay, so the drawing is correct. So this is the answer for this one. Okay, you can try this on your own. Okay, and this one also the same thing, you can try. Maybe you can pause this video and try to answer it first. And this is the answer. And this one, what is the name for this structure? Okay, the clue for you, we have functional group alcohol at the side chain, so you should name the side chain. You should give the priority to the side chain as the parent chain. Okay, so it is 2-butanol actually, the parent chain, and there is a lot more naming that you can do. Okay, next one, physical state. Okay, physical state. Physical properties. Physical state is physical properties. Physical state for alcohol that have less than 12 carbon, ethanol, propanol, hexanol, all the way up to 12, is in liquid. The state for it is liquid and colorless. More than that, above 12, it is solid. Okay, so the alcohol present as solid if you have 12 carbon in it. And phenol, okay, phenol is the benzene with OH group, so it is colorless liquid. Okay, now we want to see at boiling point. Okay, so this one is easy to look. Molecular weight, the higher the molecular weight, the higher the BP. BP is boiling point. Due to van der Waals forces that is much stronger. Okay, so boiling point increase because van der Waals forces increase, and also due to molecular weight that is increased. Okay, the second factor is when you have higher number of hydroxy group attached in that compound, boiling point also increase because OH group can form a higher number of hydrogen bond. Okay, boiling point of alcohol is higher than corresponding hydrocarbon. It means that if you have ethanol, for example, ethanol, you want to compare with ethane, which one have higher boiling point? So of course ethanol, because ethanol or the alcohol have the ability to form hydrogen bond. It can form hydrogen bond, whereby ethane cannot form hydrogen bond. Okay, and next one is about the branching. So straight chain alcohol, let me draw. Let's say we have this structure OH. Okay, compare with a branch. Okay, this one branch and this one is straight chain. So straight chain alcohol will have higher boiling point because it has larger surface area of contact, whereby this one become more compact. Okay, so there will be a lot more of surface area, whereby this one having smaller surface area. Okay, so straight chain has bigger contact area compared to branch alcohol, which is more compact, so stronger van der Waals forces for that straight chain. Okay, solubility in water. Okay, alcohol that have lower than 5 carbon means that if we list all of the carbon here, it means ethanol, methanol, propanol is 3, butanol, and pentanol. All these are soluble in water due to the presence of hydrogen bonding. Why does it have hydrogen bonding? Because the presence of OH group. Okay, so let's see for this one. This is water. And this one is alcohol. So it can have the interaction. This is the hydrogen bonding. This is the hydrogen bonding between alcohol and water, So when it have that interaction, it is soluble. Okay, that is shown to you, H bond or hydrogen bonding. But if you have longer carbon, more than 5 carbon, it is insoluble in water. Why? Because if I draw, let's say I have hexanol, 1 2 3 4 5 6. Okay, so OH is here. So you can see that this is what we call alkyl portion. Okay, and alkyl portion here is hydrophobic. Hydrophobic means afraid of water or didn't like water, and it is non-polar. Water is polar. So what happened is the alkyl portion is too large to be dissolved in H2O. It does not have that interaction. Non-polar cannot be dissolved in polar solution. Water is polar, so it does not have interaction. It cannot form hydrogen bond. Okay, so that is the R. So hydrophobic part, so it have weak interaction with water molecule. Hydrophilic part, it is polar, but it cannot have it have that hydrogen bond, but the hydrophobic or the alkyl portion is much larger. Okay, next one, solubility in water. Okay, this one about same number of carbon, eh? If you have for example, okay, let me draw the structure. Okay, here you have one hydroxyl group, this one you have two hydroxy group, and this one you have three hydroxy group. So the larger the number of hydroxy group that you have, the higher the number of hydroxy group that you have, it means you will have more solubility, more soluble in water. This one have two, whereby this one have three. Okay, this one have three hydroxyl group. So if we compare A, B, C here, we can straight away say C is much more soluble in water because it have the same number of carbon. The number of carbon is the same. The alkyl chain here is same. Alkyl chain is the same in terms of the number of the carbon. What's different is the number of hydroxy group. So C is the most soluble, and the same thing for boiling point. Because it can form more hydrogen bond, it will be more difficult to break the intermolecular forces. Oh, this is carnival science before this. Okay, so you can try to answer this question. Okay, test yourself. Arrange in order of increasing boiling point and solubility in water. Okay, and the answer for this one: hexane, butane 1,4-diol, and propane 1 or 1 propanol. So for boiling point, which one is the highest? Okay, boiling point increase. The one which have two hydroxyl group. Okay, because it can form more hydrogen bond. Solubility in water. Okay, hexane is the non-polar hydrocarbon, so lower solubility. 1 pentanol and 1 butanediol are polar, so it can form hydrogen bond because there is the presence of because it have hydroxyl group. But 1,4-butanediol have more sites for the formation of hydrogen bond than 1 pentanol because it have two OH group. Okay, this one is next class. Okay, so that's it for the topic of alcohol 5.1 and 5.2. Next class we are going to proceed with preparation and reaction. Okay, so good luck. Bye.